Hey guys, it's me, Raphael. Before I even start, I just wanted to say that this was taught to me by a paramedic preceptor where I work, which is in care flight. I want to give full credit to him. His name is going to be Michael Carrillo, and he taught me a little way of how to get my mathematics going on for this pharmacology, and I just wanted to pass it on. I know one of you asked, and I just wanted to see if it helps you guys. So he gave me a problem, which is, let's see, let's go down here. It's going to be, sorry if I misspell it. Propofol, I think propofol is what it is, and he said it's very common. He told me that the dosage was going to be 7.5 micrograms per kilogram per hour. If everyone can see that, right? Awesome. And he said we're going to do it on a patient who is 140 pounds. All right. And our concentration is going to be 25 milligrams in a 100 ml bag. And this is just an example. This isn't actually something that's out of the book or anything. He called this the train track, which I found pretty fascinating, and it helped me a lot in having to figure out what to put what on where. So what we're going to do, we're going to start with our dosage. And he says you want to put mils over time or mils over kilo all the time. So we're going to put 7.5 micrograms, which is going to be our dosage, over 1 kilo. And then our time is going to be always at the bottom. And then just to help us out, here at the end, we're going to put what we're looking for. So we're looking for mils over hour. And I'll explain that to you here in just a second as well too. Alright, so now that's one piece of information, correct? We also have our time, which is going to be 1 hour, or we can just put hour right here at the bottom. Now let's change this pounds real quick. Pounds, doing the math, you divide it by 2.2, and it's just going to be roughly about 60, we'll say 63 kilos. Alright, 63 kilos, right? So we're going to put 63 kilos down here. Now what else do we have? We have our concentration, correct? And again, mils is going to be on top. Mils over, what is it? 25. Milligrams. Alright, so far we got this, right? That's the information that we got. Now, what we're going to end up doing is we're going to be breaking up, kind of canceling out, is what he was telling me. So if we do this, what can we cancel out here? We can cancel out kilos, which is right here, and then kilos on top, which is right here. Alright, now we need to, once again, look for mils per hour. So let's see if we can cancel out micrograms. So if we go 1 milligram equals how many micrograms? It's going to be 1,000 micrograms, correct? 1,000 micrograms. So now what can we cancel out here? We can cancel out this one, that microgram, and we can cancel out this microgram. Alright, we can also cancel out this milligram, right? We can cancel out that milligram. So now all we're left with is going to be mils over hours. And that's our math that's done. So basically we're converting. We're putting our information in it. And we're going to get with our end result, which is mils per hour. And I'll explain that to you here in just 1 second, why we're doing mils per hour. So if you do the math, you go straight across. 7.5 times 63 times 10, you should be getting 47250 mils. And if you do 25 times 1000, you should be getting 25,000. Okay, so if you divide that out, you should be getting roughly 1.89 mils per hour. Alright, now with that, you're saying, well, we need to find out drops per minute. Cool, so let's do that. Ready? So that is going to be 1.89 mils over 1 hour. And then we'll do the train track all over again. Alright, so how many mils, or let's do time first. So in 1 hour, there is how many minutes? 60 minutes, correct? Now let's do another train check right there. So we can cancel out hours. Bam, right there. Now, how many drops make 1 mil? Since we're using a 60 drop set, we'll put 1 mil, since we're trying to cancel out mils. So you got to put it in the opposite direction. So 1 mil is 60 drops. GTTS. So we're looking for drops per minute. This is going to be our end result, what we're looking for. Alright, so here we can cancel out this one, and we can cancel out this one, which canceled out mils, right? Mils and mils, and then we did hour and hour, so which gives us minutes per drops. But in all due reality, we can cancel out the 60s because they will cancel each other out, which will leave it one on top and one on bottom, right? If we cancel those out. So in all due reality, it's going to be 1.89 drops per 1 minute. So you're back left with 1.89 drops per minute. So why he told me to leave it in mils per hour is he said, you know, with every pump, that's basically what you're going to be doing. I know we haven't learned that yet, but he said whatever it is mils per hour, it's also going to be drops per minute, which was pretty cool. I didn't know that, and he explained it to me, and it makes perfect sense. So hopefully, if you want, you can watch this video again, see how I explained it. We're going to always be looking for mils over hours, and you're always going to start with micrograms over kilograms, and just go on from there. You know, your concentration is going to be over here. You're going to want to cancel out whatever you can, hours, and mils over is going to be on top. See, micrograms, milligrams, and then eventually you're going to cancel everything out. So whatever you can with, you know, obviously my milligrams had to be on top here to cancel this one out. You're left with micrograms over here, but then you canceled micrograms and micrograms over here. So all in all, it works. Whichever way you decide to do it, it works. I tried to do it multiple ways, and I always got the same answer, which was really odd. So hopefully you enjoy this and see if it helped you guys. Alright, thanks.